Today we're going to begin section 4.2, and the objective for today is to define the 6 trig functions. So the first thing we're going to discuss is what are the 6 trig functions. So up until this point, you've been introduced to only 3 of the trig functions. So you are aware of sine, cosine, and tangent. And that's something that you learn in geometry and you learn a little bit in algebra too. So we're going to discuss the spellings of each so you understand the abbreviations and then the other 3. And the way I'm going to set up these 6 trig functions is the way we're going to kind of set them up all throughout this chapter 4, 5, and 6 whenever we're figuring out the trig functions. So the first one we're used to is sine. And notice the way we abbreviate it is just SIN. The next trig function that you know about is cosine. And the abbreviation for cosine is COS. And the last trig function is tangent. And the abbreviation for that is just TAN. So those 3 we're aware of. The new 3 trig functions that you have not learned about, the first one is called cosecant. And notice I'm lining this one up right next to the word sine, and there is a reason to that, and you'll kind of learn that as we go. Abbreviation for this is CSC. The next trig function is secant, and the abbreviation for secant is SEC. And the final trig function is cotangent. And the abbreviation for cotangent is COT. And as you're looking at these 6 trig functions, not sure if any of you noticed this, but if you didn't, I'll point it out. Notice there's a sine and then there's a cosine. There's a tangent and there's a cotangent. There's a secant and a cosecant. So all of these kind of have these partners, which is implying this co part of it. So keep that in the back of your head. Next thing we're going to discuss is defining what each trig function means in terms of the unit circle. So before we get into that, I'm going to just kind of go back to something that's a little concrete to us, which is SOHCAHTOA. So if I have my axes here, and here's a circle, now obviously part of it got cut off, but that's okay. And I'm going to draw within this, I'm going to draw a triangle. So here is my right triangle. And we're going to put our theta over here. So in terms of what we know, if my theta is here, this side's my opposite, this would be my adjacent, and this one would be my hypotenuse. So now we're going to kind of redefine this in terms of x, y's, and r's. So the adjacent side, notice, is lying on the x-axis. My opposite side is lying on the y-axis. And my hypotenuse is what we call the radius in terms of the circle. So we are familiar with SOHCAHTOA. And this is something that we're going to kind of phase out. So you're not necessarily going to hear us talking about opposite, adjacent, and hypotenuse anymore. Instead, we're going to talk about x, y's, and r's. So you should have this picture drawn on your screen. I'm going to flip to the next page so I have room to write, but I want you to look at this picture as we define the trig functions. So sine of theta is opposite over hypotenuse. Now looking at the pictures in terms of x, y's, and r's, sine is y over r. Cosine of theta is adjacent over hypotenuse. Looking at the picture, that means x over r. And lastly, tangent was opposite over adjacent. So that means it is y over x. So now the other 3 trig functions, again, I set them up for a reason. So my cosecant is always written right next to sine, and the reason for that is that they are the reciprocal of one another. So cosecant is r over y. Secant of theta is r over x. And I'm sure you could take a guess and figure out that cotangent is x over y. And I'm going to tell you my silly way to help you remember this. Again, it's totally goofy and silly, and it doesn't make much sense, but my goal is that it helps you remember the trig functions. So it's why are you sinning? 'Cause I was exercising. So again, it's why are you sinning? 'Cause I was exercising. Tangent, I don't really have a saying for that, but notice that tangent is y over x, and the way we have it set up, that sine has the y here, and then cosine has the x there. So that's my goofy way to help you remember it. I'm not saying you have to use it, it's just my little hint. So before we get into using the definition of these 6 trig functions, I just need to give you a quick definition of the unit circle. Okay, so a unit circle has a radius of 1 with the equation of x squared plus y squared equals 1. So I'm going to give you several points, and we're going to assume that the coordinate that I'm giving you falls on the unit circle, which is implying that the radius will be equal to 1. So for my first example, if the point is negative 1/2 and a root 3 over 2, and again, we're assuming that this falls on the unit circle. That means we know an x value, I know a y value, and it's implied that the radius is 1. And the directions will say define the 6 trig functions. So leave a little bit of space here. We're going to have to go over some fraction rules for this section. So for the first one, sine of theta is equal to y over r. So my y value is root 3 over 2. My r value is 1. So when I divide this by 1, it stays root 3 over 2. Cosine is x over r. So I simply take my x value of negative 1/2, divide this by the r value of 1, and it stays negative 1/2. So sine and cosine, not much work. I'm going to switch the screen so I have more room. Tangent is y over x. So this one I'm going to have to do a little bit of work for. So my y value is root 3 over 2 over my x value of negative 1/2. So we need to divide fractions, and the way we do that is keep, change, flip, or multiply by the reciprocal, whichever saying you learned in middle school. So I keep the root 3 over 2 because that's the overall top fraction, and I'm multiplying it by the reciprocal of the denominator. So I have negative 2 root 3 over 2. Notice I have a set of 2's in the top and the bottom, so they can cancel, and I'm left with my final answer of negative root 3. So that's just the first 3, the sine, cosine, tangent. Now what we're going to do is find the other 3. So again, I'm going to switch screens so I have more room, and just to kind of recap, I know my sine value is root 3 over 2. Cosine of theta was negative 1/2. And for my tangent, oops, what am I doing here? And tangent was negative root 3. So we've done all this work, so now we have to find the other 3. And the other 3 typically aren't as difficult. So cosecant is r over y, which essentially is the exact opposite of sine, which was y over r. So I'm going to take my sine value, and all I have to do is flip it because that's what the fraction did. It flipped. So when I flip it, I get 2 over root 3. The only issue is one of the rules says is you can't leave a square root in the denominator, so we have to rationalize. And to rationalize, you multiply whatever that square root is from the bottom to the top and the bottom. So I'll get 2 root 3. In the bottom, the square root of 3 times the square root of 3 is the square root of 9, which bumps you right back down to 3. So that's cosecant. Secant is r over x. Now remember, cosine was x over r. Now I have r over x. So again, it just flips. Cosine's negative 1/2, so secant is negative 2 over 1, which is just negative 2. And lastly, cotangent is x over y, which is the exact opposite of tangent. So you have two options here. You could go back to the coordinates and set it up by saying x over my y, or I could just take this tangent value and flip it. So right now, tangent is negative root 3, like over a 1. So when I switch it, it becomes negative 1 over root 3. And just like in that first scenario for cosecant, we have to rationalize. So I have to multiply by the square root of 3. So I get negative root 3 over root 3 times root 3 is the square root of 9, which bumps it right back down to 3. So those are your 6 answers for that single coordinate. So that's all for today. We're going to pick up with this tomorrow.